Today, we're introducing you to a scientific claim that could fundamentally shake the secrets of the universe. In his striking new study, Dr. Rajendra Gupta of the University of Ottawa not only says the speed of light is slowing down, he also argues that the universe is twice as old as we estimate, a full 27.6 billion years. We are examining this groundbreaking paper together and asking the question that could rewrite the history of the universe. What if it all begins with the speed of light changing? So, why would Rajendra Gupta from the University of Ottawa want to shake the very foundations of modern cosmology, even at the risk of his own career? The answer lies in two great mysteries that have occupied the scientific world for decades: dark matter and dark energy. This is precisely Gupta's starting point. Instead of inventing new particles or energy forms for these two great unknowns, he asks a much more fundamental question. What if the rules of the universe aren't as constant as we thought? So what exactly does this new model say? In standard cosmology, there's a scale factor that describes the expansion of the universe. To simplify it greatly, it's like a number that shows how much the universe has grown or how much the cake has risen. If we call today 1, in the past, this number is less than 1, and in the future, it will be greater than 1. The point is, this factor is variable. It changes from the past to the present. He begins his paper by asking, if the expansion of the universe is variable between cosmic eras, could other constants be variable too? He also notes that this question has already been partially answered regarding the speed of light, and he adds the tired light hypothesis to his model. What is this tired light, you ask? When astronomers look into the depths of the universe, they see that light from the most distant galaxies has redshifted. The standard model says this is normal. As the universe expands, light redshifts, its wavelength stretches. But this is where the tired light hypothesis, first proposed by the famous physicist Zwicky, who also first identified dark matter, comes in. It asks, what if the only reason for the redshift is an expansion? According to this hypothesis, light, during its billions of years of cosmic travel, loses energy. It gets tired, like a marathon runner, independent of expansion. This photon, losing its energy, redshifts. In essence, in the paper we're discussing, Gupta states that the proposition of a non-constant speed of light is not new. After this stage, Gupta adds a second scale factor to his paradigm-shifting model. But this new factor doesn't scale space itself, it scales the laws of physics. What does this mean? It means the speed of light is not constant throughout the eras of the universe. And he doesn't stop there. He argues that gravity per unit of matter is also variable, and that the changes in these constants are synchronized with each other, consistent with existing physical theories. He says this change is on a cosmic scale, woven into the fabric of the universe. He then adds that this isn't a change from one day to the next, but its effects span all eras. According to this model, the fundamental pillars of nature, like the speed of light, the gravitational constant, and the Planck constant, are not actually constant. He states that this change between eras can be calculated with a parameter he calls the alpha factor. This sounds great, very cool, and very ambitious. But what do these statements mean for ordinary science enthusiasts like us? Let's think of the universe as a giant video game. The Big Bang is the day this game was released as version 1.0. The game's most basic rules are written in a code set we call the physics engine. These codes contain the most fundamental settings, like how fast everything in the game can move and how strongly objects will pull on each other. Until now, we assume these physics engine codes haven't changed since the first day of the universe, that we've always been in version 1.0. Here is this paper's claim. The universe has been continuously releasing small patches and updates to the game for billions of years. One of the biggest changes that came with these patches was the gradual lowering of the game's maximum speed limit, the speed of light. This means that in the early versions of the game, information could travel much faster than it can today. To fully see the picture of the speed of light the author is proposing, let's make this slow down concrete. According to the paper, the moment the speed of light was highest was the Big Bang. Although the author predicts a speed of light that slows over time, he hasn't done this calculation directly. However, by taking the generally accepted Hubble constant and assuming the 13.8 billion year age of the universe is correct, and then basing it on the model in the publication. According to a rough calculation we did, the speed of the first light, which emerged 380,000 years after the Big Bang, is approximately 560,000 kilometers per second. The graph you see on the screen shows how the age of the universe changes between eras according to the paper. This graph is the big picture the author presents to us. But let's be clear, this calculation wasn't done by the author, but by us as ordinary science enthusiasts. And while the values likely don't reflect the exact truth, they do reflect the author's idea. If this claim is confirmed, it really, truly means that every physics book will have to be rewritten. Why? Because the theories of general relativity and special relativity would need a thorough overhaul. Does the author test this incredibly bold model with existing data? The answer is yes. The author doesn't just stop at theoretical propositions. He designs a test based on real data. He applies his proposal to the sparse regions of the NGC 3198 galaxy, 0.37 kiloparsecs out. The results are interesting. The graph you see on the screen right now brings us to the breaking point of the paper. So let's first understand this graph thoroughly. The graph roughly shows the rotation speed of stars in the NGC 3198 galaxy. The vertical axis shows the rotation speed of the stars around the galaxy, and the horizontal axis shows the star's distance from the galactic center. The red line, which is the star speed curve that should result only from visible matter, starts to decline after a certain point, as expected. However, the blue line, the actual observation, shows that the stars in the outer rings don't slow down at all. On the contrary, they continue to rotate at a nearly constant, high speed. This is a huge problem, because to maintain this speed, a massive amount of unseen mass must also be pulling on them. The solution that the standard cosmological model found for this massive missing mass problem is called dark matter. This is exactly where Gupta's model enters the stage, asking, but what if the thing you're looking for isn't a particle? He poses the test question, if the acceleration attributed to dark matter is actually caused by the periodic decrease in the speed of light and the temporal increase in gravity, then if I remove the effects of my model from the observed star rotation speeds, I should get the speed that normal matter should be causing. By the way, the normal matter estimates for galaxies are kept in a database, meaning we have generally accepted values for galactic normal matter. At this point, the author conducts his first serious test. He takes the matter quantity calculated by his model and subtracts the effect of the slowing speed of light and the increase in gravity, obtaining the graph you see on the screen now. Frankly, the result isn't bad at all, although not equal to the generally accepted normal matter amount in the database. The values obtained seem compatible. According to the author, his model has passed this test. So, where does this extra gravity or the slowing of light on a cosmic calendar come from? Or why does it activate in the quiet outer layers of galaxies, but not in the dense regions? The author's explanation is as follows. The fact that the speed of light hasn't been constant for billions of years has embedded a potential energy into the fabric of the universe that we normally can't see. This potential is suppressed and remains ineffective in places where matter is dense, like the galactic center. But as soon as the matter becomes sparse, this sleeping inheritance awakens and reveals itself as an extra gravitational force. Think of it this way. You can't hear the ticking of a clock in a noisy place. But if you take that same clock into a quiet room, you can hear it, even though the clock's sound hasn't changed. In short, according to the paper, the value of the speed of light is the same everywhere right now. But a ghost effect created by its past variability only emerges in desolate places. However, the paper does not provide an explanation for the source of the slowing speed of light. Actually, the periodic slowing of the speed of light has another significant implication, that the age of the universe might be completely miscalculated. To put it very, very simply, we fundamentally calculate the age of the universe from its expansion rate. We get this expansion rate from the amount of redshift in the light from distant galaxies when it reaches us. However, this calculation assumes that the only cause of redshift is the expansion of the universe. If the cause of redshift is not just expansion, and if, as the model suggests, the tired light effect is responsible for part of this redshift, then we must remove this tired effect to calculate the age of the universe correctly. The redshift used for the age calculation would then decrease. This would show that the universe's expansion rate is actually slower, and therefore, it took longer for the universe to reach its current size. In other words, the universe could be much older than we thought. Subsequently, the author calculates the age of the universe with his own model, and the value he gets is 26. 7 billion years. That's almost twice what we currently know. At this point, the author presents an important argument by referencing the latest data from the James Webb Space Telescope. Webb's observations of the early universe showed the formation of unexpectedly large galaxies in an era when, according to the Standard Model, the universe was much younger. The size of these galaxies, relative to their age, appears too mature and dense to have formed in a limited time span of 13.8 billion years. The author explains this situation within the framework of his model. If the universe is actually 26.7 billion years old, then there was sufficient time for the formation of these advanced galaxies observed in the early period. And he adds, in fact, this finding itself can be considered significant evidence for the validity of the new model. Some of you might say I've described this new model as if it's an accepted fact. However, this model is still in the hypothesis stage. It has not been tested by multiple independent observations. Moreover, we see that multiple criticisms have already been leveled at this paper, even though it was just published. And while these criticisms might include a bias toward protecting the status quo, many of them have valid points. The first is that we don't just have one measurement to determine the age of the universe. We arrive at the same conclusion using many different methods. However, Gupta's calculation is based on only one type of observation. Many say it's difficult to call this approach correct until it is expanded. Additionally, there are those who ask, if the universe is really 27 billion years old, why haven't we ever seen a star older than 13 billion years? The tired light hypothesis contradicts many other phenomena, such as time dilation in supernova observations and the cosmic microwave background. It's noted that the model doesn't explain these discrepancies. Science lovers, today we came to you with a very new and very ambitious paper. To meet right after similar papers are published and to contribute to the dissemination of science, you can subscribe to our channel, like our videos, and press the join button.